I'd like to show a little bit of how I actually manufacture these parts. I have SolidWorks, and it turns out that Autodesk has a free add-in called HMS Express, and that add-in allows you to do 2D parts. Now, of course, they give that to you for free because they're hoping you're going to buy their $3,000 or $4,000 a year HMS Works. But for me, the 2D works well enough. When you look at the entire set of parts and the toolpath assembly here necessary to manufacture them, it does seem a bit overwhelming. I don't think about it that way. That's too much work. I start doing one set of parts at a time and work my way from one side to the other. Here's one set of parts here, and the idea is that it's probably easier to manufacture these isolator offsets and then outline them and remove them from the plate before starting to work on these parts. And you can see that there are some possibilities when you are machining the outer ring here and this inner ring piece here, that as you machine and outline this part and you machine and outline this part, there is going to end up being potentially some material in here that is not machined. And the idea, the problem can be that as you're machining the final pass on this part, you can pick up that material and throw it. And that material can throw itself into this gap. And then as you keep going, you'll hit the material and it'll break. So machining is in this way, where I'm machining everything out of one plate, you really have to look for possible errors or possible danger spots. In some cases, you can machine these fine. It might work perfectly 20 times in a row, and then one time by random chance, that chunk of material will get jammed and you'll end up breaking a $50 or $70 tool. I'm going to show a little more detail on something that's just a bit easier to show, and that's the weapons mount plate. Here you can see the very first pass in manufacturing this plate is actually a clearance pass for material that's left over. Again, in the same vein as before, when you machine the outline of this part here, it leaves a big hump of material. And if you are just outlining this part with this path here, then there's a big chunk of material your cutter is going to pick up and throw. Probably would be okay, but I don't like to take the chance, so I machine that stuff away. In some cases, like in the center of these, there's actually a couple of holes available, and I drill and I bolt the centers down, and I just outline this part on the inside, and the piece of material will be left over, but it's bolted in place, so it's not going to be picked up and thrown anywhere. When you run the pathways of these parts, you can look at and see a lot of things about how your cutters are moving. An easy thing to look at is from the side, you look at what are your clearance planes. Does everything look like it's retracting to the same level? I'm pretty generous with my clearance planes. I tend not to try and make them too tight, because sometimes a little piece of material can pop up and be sticking up, and I don't want that to break a tool. So you can work your way through your entire machining process here, and at varying speeds. But if you really want to know what it's going to look like, one option is to use their simulation that does a voxel representation of the material. And this is very rough. And that's because I'm using the free version. I believe that their expensive version of this simulation actually has much higher levels of detail. This looks pretty ugly. And if you remove the reference parts, it's kind of hard to tell whether it's going to work or not. Luckily, there is a way to zoom in and increase the density of the voxels. And so that is a better representation. Still, it's not great, but if there was something that happened, like a tool failed to come up high enough and exited this pocket, you would see the removed material from the voxel representation. If you really truly want a higher definition, you can zoom in yet again. Now you have a much higher fidelity version. And again, obviously this isn't going to show you everything. But if you have an area that you really want to verify that, you know, like this wall is not being gouged into, or that your chamfers here are about the right size, you can zoom in and take a look and be fairly satisfied that it's going to work. So the idea is that plate by plate, this gets programmed, and again, since it's in SolidWorks, if you decide to change something, like you decide to change the location of these drill holes, they move automatically with the SolidWorks model. And coming from a background of CAM programming where you had to take the SolidWorks model and essentially export it as a fixed model and then use a program to cam it, and if you changed anything you had to start from scratch again. This is so much nicer. After all four are programmed and run, then I will do some test fitting, and if everything seems to work correctly, then I'm going to continue and make the rest of the plates.